name is Justin Kitagawa, and I'm one of the founding engineers at GoGrid. I'm currently a lead software engineer there, and I'm responsible for the virtualization team. When I first came to GoGrid, I was tasked with building a portal, and I designed and built our portal and our API. So, who's GoGrid? We are a global leader in hybrid cloud infrastructure. We provide cloud data centers where customers pay on demand for infrastructure that they use. And our infrastructure consists of interconnected servers, load balancers, firewalls, network, and storage. To us, cloud computing equals a completely outsourced IT infrastructure. All of this is possible through GoGrid's portal and our API. Our API is a REST-like query API. You access it at https://api.gogrid.com. We designed it to be easy to use. We really wanted to facilitate and enable developers and system administrators to be able to provision servers on demand. It's stateless and uses HTTP, gets and posts. When we built it, we wanted it to be language agnostic, meaning we didn't want to be particular to one particular language. So whether you're a .NET developer, a Java developer, PHP, Python, Ruby, Perl, or even Bash, if you're a system administrator that just wants to use a shell script, we wanted to facilitate and make the API accessible for you. Kind of an overlying metaphor with the API is that every API request really is a combination of an action and an object. An action representing the verb and an object representing a noun. We'll get to what are the actions and the verbs a little bit later. But some examples are, for instance, add server or list a load balancer. An API client will make a request to our GoGrid API REST server, and we parse the HTTP parameters, we do our processing, and we then send you back a response. Every API request has 3 required parameters. First off is your API key. The API key is auto-generated for you via the GoGrid portal. So through the portal, you can just go add API key, get an API key. When you create an API key, you also have to specify a secret. A secret is essentially a password, if you will. So the API key is kind of like the username, and the secret is your password. We require the clients to generate an MD5 signature, which is comprised of a concatenation of the API key, your secret, and a Unix timestamp. So this is a timestamp from the Unix epoch, which is January 1st, 1970 GMT. You concatenate that all together and then run an MD5 encoder on it, and then that's your signature. The V is version. So this is to support backward compatibility. And currently, right now, we're on 1.4. One of the nice features of the API is the ability to choose your output format. By default, we output to JSON, which stands for JavaScript Object Notation, XML, or a comma separated value, CSV. So this is really kind of making a sample request. This request is adding an 8 GB CentOS Linux virtual server accessible at the public IP 192.200.10.101. If anyone has constructed HTML or made a HTML form or just even looked at the URL bar in your browser, this should be very familiar to you. In the URL itself specifies what is the method. In this case, a grid server add. So we're adding a virtual server. You specify a handle for it, which is kind of a friendly name. This is what we have in this example. It's called my first server. The image is our concept of a GSI. In Amazon, they're called AMIs. And this is the machine image. It essentially is a representation of the bits that are going to be instantiated onto your virtual server. You can specify the RAM, IP, and then you can see those insert parameters that were built. Here's some example of some code that, in this case, I chose a bash script, just to kind of show that it's very easy to use, and just even from a very basic programming language, in this case bash, you're able to instantiate a virtual server. Objects that are supported via the API are servers, images, which get spawned and create servers, load balancers, IPs, passwords, and jobs. Jobs are a representation of an asynchronous command. Every API request will instantiate a job, and via the job you can query to see your status of a job that's occurring. When you make an API request, it's important to note that we're not actually instantiating a VM right there. We just really reserve the instances and send it back. So some challenges that we had. We wanted to keep it simple. So when we had the opportunity, did we want to choose SOAP, a full REST-like API, or kind of a hybrid that we called a REST-like or RESTful API? We chose the latter just because we wanted to support, with SOAP, it's very heavyweight. Like even with Java, if you were to instantiate a Java and generate an API from a WSDL, sometimes you might need up to like 20 megabytes of libraries just to do that. We wanted to make it very easy to use. In terms of having a full REST API, we wanted to kind of just use paradigms that kind of existed, and HTTP gets and posts, most in all languages really support that. Some of the other verbs sometimes are a little less supported. It was important to keep consistent terminology throughout. So using common verbs, add, delete, edit, is also important. Another thing that we like to do is we're liberal on our inputs and conservative on our outputs. That means that we want to try to accept as much information as possible and then send it back out to you. Versioning and backward compatibility. This is a problem when designing and building an API, so we kind of have some rules that we abide by. One, when we, on attributes to objects, we only add attributes. We'll never take them away. And for parameters to API methods, once again, we'll never remove them. Sometimes we'll overload them, sometimes we'll do other things, but always in an effort to maintain backward compatibility, we keep what exists. We have a lot of test harnesses also that are running regressions. So, who and what is all this for? So just a show of hands here. Who here wants to leverage cloud infrastructure to improve the efficiency of their engineering team's development, staging, or production systems? Then it's for you. And I recommend that if you do not use any of the cloud APIs here, I really recommend you take a look and see what our panel here has to offer in their products, because we are all about enabling and helping you. Thank you.